Hello, anybody response please? Is it visible? Okay. So it is full screen right now. Okay. So good evening to all of you. Today is the third week doubt clearing class. So we are discussing on the topic characterization of polymers, elastomers and composites, already taught by Professor Santanu Chattopadhyay. And here I am your PA assistants. So first week we have discussed about basics of polymers, and second week we have discussed about characterization and testing, difference between characterization and testing. And today we will discuss about chemical analysis. So I have already told you that there are different analysis technique. So one of those analysis is chemical analysis. There are others like morphological analysis, structural analysis, thermal analysis. So those we will discuss in upcoming week. Today we will discuss about chemical analysis. So under this broad spectrum of chemical analysis, there are different subcategory like raw materials, uh, primary or preliminary tests you have to do before using those raw materials to process or to compound your uh, polymer. Then elemental analysis and other special tests for specific polymer or specific chemical. So if we divide raw materials, so there are basically two components. First is the base polymer. So you have to choose some specific base polymer based on your final application. And then the in other category there are multiple components like additives, plasticizers for smooth processing, curing agents to cure your base polymer, and others chemical composition also. So in chemical analysis part there are different uh, uh, analysis technique. So nature and purity of your raw materials, quality control of your polymeric materials, and analysis of the final product. So you have to do chemical analysis of your raw materials to produce your final product, and again after producing your final product you have to do some testing and analysis of the final developed material. Basically this part is mainly applicable for reverse engineering purpose in different R&D section. So in raw materials, for example, if it is a final product is tire, so there are different raw materials. The base is obviously a rubbery material or elastomer. There are fillers, there are curing agents and other processing aids. Now first when you are getting a materials from your supplier, so first you have to check the by visually what is the texture and color. Let's say if it is a natural rubber, you are getting in a sometimes in a sheet form or bale form. So you may see the color of NR usually in brown type color, but depending on the intensity of that brown color, the property actually varied. So sometimes because of some restriction like during the corona time, there is a problem in supply chain. So sometimes you need to purchase from different new supplier. So based on the visual appearance, first you have to check the visual appearance, and obviously if there is changes, so there may be changes in the property. So this is also important. The next is physical property that you need to check, like for filler the particle size, for other chemical ingredients the morphology or texture or its melting point, its boiling point, you need to check before going to the bulk processing, and obviously ultimately the chemical properties of your material. Here I have given some examples of base polymer, basically elastomer. So first one is the natural rubber, and from the structure you can say there are mainly two elements, that is carbon and hydrogen. In case of butadiene, there is also only carbon and nitrogen. But in case of chloroprene, this is the chloroprene rubber, there is also presence of a halogen group. Here it is chlorine. For nitrile rubber, there is carbon, hydrogen, and also nitrogen. In case of styrene butadiene rubber, it is only carbon and hydrogen, but there is also a presence of phenyl ring. So there may be different observation during different chemical analysis. We will discuss one by one. So in first preliminary test, first what you should do for a base rubber, that is the ignition test. You take a small sample from a bulk amount of rubber, and through a spatula you hold in a flame and then see what is happening. Based on your base polymer, there may be appearance of smoke, there may be different smell, and also there may be variation of the intensity of the smoke. Different rubber will show different type of smoke also. This is very simple test, but from here you can also guess little bit. For example, if you are getting natural rubber from different supplier, if there is difference here, that smoke intensity or something else, there may be some changes in your base polymer. The next is the pyrolytic test. In case of pyrolytic test, the rubber is heated in a special glass apparatus. So here you need a high temperature to make the base rubber and to generate large amount of smoke. And after getting that smoke, you will do different test. So here I have put a table, and different rubber will different rubber will show different behavior during different preliminary test. So first one is natural rubber. So what is the observation during the ignition test? That smoky flame with distinctive odor, and flame continues during burning. That means when it is inside that flame, and when you remove from the flame, still the burning is continued. And why the odor is coming? You know that in case of natural rubber, as it is purely natural based, so there is a large amount of proteins or different biological molecules present in natural rubber, and then that will create different odor. In case of pyrolytic test, the dark color liquid distills out. So, and if you boil with a concentrate H2SO4, that is 80% concentrate H2SO4, the rubber will decompose. But in case of SBR, the flame is different. It's not smoky flame. It is sooty type of flame, and sweet odor is actually you can smell. Now, why the sweet odor is coming? Now, as here I have shown you that because of this aromatic ring, so we know that aroma means it smell. So because of that, after burning, it will create different odor. In case of pyrolytic test, there is not that much of significance observation, and in case of concentrated H2SO4 boiling, it will decompose. So actually, because of that much of high concentration H2SO4, almost every rubber will decompose at that condition. In case of BR, there is also smoky flame and continuous burning when you remove it from the flame. But the difference is, if it is CR, that is chloroprene rubber, it will burn when it is inside the flame, but if you remove it from the flame, it will automatically the it will be extinguished. Now why this happen? This is because of the presence of halogen. So you know that usually halogenated rubber like chloroprene are used for the fire retardant application, because when the you will remove it, that halogen actually enhance, actually create the uh, difficulties further propagation of your flame, and the formation of radical actually scavenge the uh, further radical generation, and it will extinguish the flame. In case of pyrolytic test, the acid liquid distills means you may check it that some liquid type of droplets will come if you put in the if when it is undergo that pyrolytic test, and blue litmus turns into red. So if you put a blue litmus paper in touch the liquid distills, it will turns into red type of color. That is because of that presence of chlorine. In case of NBR, in ignition test it will create the smoky flame, but in case of pyrolytic test there is not that much of significant observation. In case of silicon rubber, where silicon is present, silicon oxygen bond is present, that will create highly smoky gibbs and white ash because of inorganic nature of that silicon rubber. EPDM or EPM, it will burn with clear flame. In case of hypalon, ignition with copper wire gives green flame. That is because of the presence of sulfur. And during pyrolytic test, again it will create acid liquid distills. But during the H2SO4 treatment, concentrated H2SO4, it will remain inert. In case of PVC, that will extinguish on removal of the flame. The reason is same, because of the presence of chlorine, it will extinguish the flame when it will came out from the flame. The fluororubbers, there is also a halogen, that is fluorine group is present, but it will burn highly in flame but extinguishes immediately on removal of the flame. So you should know that because of the presence of halogen, that rubber will show fire retardant property. The reason is it will scavenge the further radical generation, and it will diminish the flame propagation nature of the it will disturb the flame propagation when it will take out from the flame. Okay. Now next is the Soxhlet extraction. So it is actually done for the compounded rubber and rubber vulcanized. So in Soxhlet, this is the Soxhlet apparatus. Here is the solvent. So you have to take some organic solvent, usually low boiling point solvent, so that it will boil and it will come through this up to here. And this is the sample chamber. Sorry, this is the sample chamber. Here uh, sample is kept here. So you have to cut your rubbery material in a small size particle, and you should put it here, and then you should boil the organic solvent. So it will come through here, and then through siphoning process it will come out again, it will come again here, and you have to do a number of cycles so that from the vulcanized or compounded rubber different additive or curing agent will come out from the rubbery material. So there is soluble part and there is insoluble part. Insoluble part is obviously the cross-linked polymer, and soluble part, there are different ingredients that you have added during the processing of your rubbery material or polymer material, that is antioxidant, curing agent, plasticizer or processing aids. So you have to separate out the soluble part and insoluble part, and then you have to do different chemical analysis. Now in solvent extraction, so first is NR. For pristine rubber you need to uh, take this solvent, that is methanol, 2-propanol and acetone. All are low boiling point solvent. In case of cross-linked rubber, that solvent is acetone, methanol and butanol. And for different rubber like BR, IR and SBR, there is 2-propanol and acetone. So in maximum case you see that acetone is there, because the acetone boiling point is around 40 or 35 degrees centigrade. So it will immediately start boiling when you put in here, and then the siphoning process will start when it will reach that level. In case of chloropin rubber, the solvent is here light petroleum ether, and also you can use methanol. For PVC, as CR and PVC both have chlorine, so you need to take light petroleum ether and methanol. And in case of cross-linked, it is acetone and butanol. Now conformation test for nitrogen. So this is the elemental analysis. So what are the different, except your carbon and hydrogen, what are the others different element? For example, in case of NBR, there is a presence of nitrogen. In case of chloropin rubber, there is a presence of chlorine. Or in case of hypalon, there is the presence of sulfur. So you need to confirm what are the different element present in your product or in your developed material. For that, what you should do, first you filtrate it. So pyrolytic process, first you burn your material, then you need to crash that uh, test tube or whatever it is, and then filtrate it. So the soluble part will come with the filtrate. After that, so this is for nitrogen. After that, you have to prepare freshly a ferrous sulfate solution, and then you add 1 drop of concentrated H2SO4 and then 2 to 3 drop of ferric chloride solution. The observation is the formation of the very deep Prussian blue color precipitate, and that will confirm the presence of nitrogen. So if you have some unknown type of rubber, and if you do that experiment and you observe that Prussian blue PPT is forming, so that maybe rubber is either NBR or polyurethane or cross-linked NBR. So this is the particular Prussian blue type color. Now what reaction is happening here? So here sodium, carbon and nitrogen, it will form the sodium cyanide, and you are adding also FeSO4, so it will react further again with the FeSO4 and it will form Na4 FeCnA6 and sodium sulfate. Now when again it will react with the ferric chloride, that will form that ferrosulfuric cyanide. So here both Fe2 plus and Fe3 plus is present, and that actually show that particular Prussian blue type of color. Anybody has any doubt here? Then please ask me. So this is for the nitrogen confirmation test. Or I will proceed. If you have no doubt, I will go to the next slide. Okay, so you understand this, so I am going to the next slide. The next is the confirmation test on the sulfur. So again, first you have to take the filtrate. So for any elemental analysis, first you need the filtrate where the soluble part already there, and then you need to add different chemical agent. So after taking the filtrate, you should add dilute HCl and lead acetate. And what the observation is, it will form the black precipitate. That PPT means the precipitate. That means solid type of material, and that will confirm that sulfur is present. So that rubber may be high polon or it may be polysulfide also. The another experiment is, you take the filtrate, you add some sodium nitroprusside, and it will show deep violet type of color. Now the presence of different color is because of the formation of different product. So when you are adding lead acetate, so it will react with the sulfide that is present in the filtrate, and it will form lead sulfide. So that lead sulfide will show the black type color, black color. And when you are adding sodium nitroprusside, so it will form this complex and it will form the deep violet type of color. And these color are basically coming from different transition that happens in the complex. So we have discussed the presence of nitrogen, the confirmation test for nitrogen and sulfur. Now here it is the confirmation test for halogens, that is chlorine, bromine, etc. So for chlorine, what you should do, first again you have to take the filtrate and add HNO3, concentrated HNO3, and you should add silver nitrate solution. Now as chlorine, if infiltrate chloride is present, so in presence of silver nitrate, it will form cardi white type of precipitate. This is the characteristic color of the AgCl, and that will confirm the presence of chlorine in your material. So if you observe this cardi white precipitate, so you may conclude that presence of chlorine, and that rubber or that polymeric material may be PVC or high polon or chlorobutyl, etc. Now in case of bromine, it will form silver bromide, and the color is obviously different from AgCl. It is pale yellow type of precipitate formation if bromide is present. So if bromide is present, that means the rubber may be bromobutyl type of rubber. So chlorine, bromine, and next is the fluorine. For that fluorine, you have to again take the filtrate neutralized with the dilute HCl, and a drop of it placed on a test paper, and that test paper, before that, it immersed in a alizarin's solution. So that is a specific solution that there is presence of different specific chemicals. So you soak in the alizarin solution first that paper, and that soaked paper, when it will placed on a dry that filtrate and neutralized with dilute HCl, when it will uh, drop on that soaked paper, that red spot will turn yellow. So alizarin's solution actually show red color when you uh, when it will react with this fluorinated chemical, that color will turns yellow, and that will confirm the presence of fluorine. So in case of Cl minus and Br minus, you just add AgNO3 with the filtrate, and it will form AgCl or AgBr based on whatever the composition is there, whether it is bromide or chloride. But in case of fluorine, you should go for alizarin test, and it will significantly show that color change from red to yellow. Now for the specific test, in case of specific group like phenyl or isoprene or isobutene that present on your base rubber, so there are different specific tests. For example, if there is a phenyl group, so the polymers are SBR or polystyrene or ABS type of plastic, you should go for the azodide reaction. We will discuss what is azodide reaction in next slide. For isoprene, that is maybe natural rubber or IR, you should go for the Kuhn-Roth method. You need to do Kuhn-Roth method. In case of isobutene group, so that is IIR or butyl rubber, you have to perform that mercuration test. And for other unsaturation, if there is a presence of unsaturation in your polymeric material, you should do that iodine monochloride test. Now what is azodide test? Maybe you have read during your class 2 or during your grade level. So first you should boil 1 to 2 gram of dried acetone extracted material with 20 ml of HNO3 for 1 hour. That is done because to do that incorporation of NO2 group. So this is the nitration part. So first you have to nitration of your material. If there is a phenyl group, the nitration will take place. After successfully doing that nitration part, you need to dilute it by pouring into a 100 ml distilled water and extract with ether. After that extraction, you have to reduce it. So first you do nitration, then you have to reduce it to NH2. So that reduction actually done in presence of zinc. So after successfully doing that reduction, you should add 0.5 molar sodium nitrite, that is NaNO. So this is basically the formation of the N2 plus, that is diazo salt. It is called diazo salt, and that reaction is very much temperature sensitive. So it must be do at very low temperature, usually 0 to 5 degrees centigrade. And why this is coming? Because if phenyl ring is present, so here you have done that nitration, that NO2 group, then when it is reduced in presence of zinc, it will convert to NO2 to NH2, because until and unless you are uh, generating that NH2, it will not undergo the formation of the diazo salt. So after successfully preparation of that successful incorporation of NH2, you should go for the diazotization reaction, that is the uh, presence of NaNO2 and dilute HCl at low temperature 0 to 5 degree, and it will form the diazo salt, and it is very deep orange type of color. And then with this, pour the diazotized solution into excess of beta naphthol. So this is the beta naphthol, this is the diazo salt, and it will react in presence of base, and it will form this type of uh, product. So how it is reacting? That base will take that proton, and this ortho position, through this ortho position it will bond with that N2, and it will form this. So it will have a different specific color. So that will confirm your the presence of phenyl group in your uh, base polymer. The next is the chromic acid oxidation, or that is called Kuhn-Roth method. So this is done to determine the presence of methyl group in your polymeric material. Now methyl group is present in isoprene because there is a CH2, CH, CH3 double bond, CH2. Isoprene, I should show you the isoprene structure. This is the isoprene CH2, CH3. That methyl group actually you need to qualitatively you need to confirm whether there is presence of methyl group or not. For that you need to go for a Kuhn-Roth method. So actually this is the oxidation of that methyl group, that is isoprene to acetic acid. So first you take 0.25 gram of acetone extracted material and add it to the digestion mixture. Then digestion mixture actually mix a mixture of 25 ml of solution of 20 gram chromic trioxide, 50 ml water, 15 ml concentrated H2SO4, and at 100 degree centigrade it will be start. After that steam distillation, and with that distilled part you go for the titration with the NaOH, and if the successfully oxidation happened, so it will in presence of NaOH and in presence of phenolphthalein indicator, the color change will be observed, because acid means there is a proton, and if you add in case of acid, the phenolphthalein color is different. In case of neutral point, the phenolphthalein color will change. So by addition of NaOH, actually you can also quantify that how much methyl group is present in your polymeric material. So at the neutral point, if you add the color will change. Anybody has any doubt? The another confirmation test is the mercuration test. So that is done for the isobutylene group detection. So this is the isobutylene group, CH2C, CH3, and there is also carbon chain. So first you need to do pyrolysis, then it will form this type of isobutylene group. And if you uh, uh, if you first you need to form that isobutylene, then a filter paper soaked with HGO, if it is dipped inside the mixture, the color of that soaked paper will turn into brown, and that color because of the methoxy isobutyl mercuric acetate is formed, and that actually show brown color. So first you need to do pyrolysis, and that will be the solution, and where isobutylene group is there, and in that solution if you dip a mercurous oxide soaked filter paper, that filter paper color will be turned into brown, and that is because of that methoxy isobutyl mercuric acetate. Now we have discussed different chemical analysis and also element analysis, the presence of nitrogen, presence of sulfur, presence of different halogenated group. Now why you should go for that chemical analysis? So first of all, there are some merits and there are demerits also. So if I talk about what are the merits, so it is very easy and you can do the analysis at a very small time, and also it is cost effective. You don't need to have any sophisticated instrument like NMR or like XRD, etc. So this is very basic elemental analysis technique, and you can at least guess what are different composition, or what are the different functional group present in your material. Now if I talked about the different demerits, that is first you need to do that extraction, Soxhlet extraction. And if you done it, if it is not done properly, so the ultimate color changes when you are adding different chemicals in your extract filtrate solution. The color changes may not be observed, and for that extraction you need to do number of cycle what I have shown in that Stochastic apparatus. So you need to do that at least 4 5 cycle, so that all the additives or soluble part will come out from your polymeric material. And the next another disadvantage is, for a small amount of sample it is okay, but the amount sample amount is very high, then it is difficult to perform that chemical analysis. And also in maximum case it is based only qualitative type of analysis. Just you are confirming what are the different chemicals or what are the different functional group and what type of rubber, but you cannot do that quantitative type of analysis. So these are the main three disadvantages that are associated with the chemical analysis technique. Now next is, so up to here we are doing on the raw materials part, all the analysis based on the raw materials part. Raw material means your basic polymer and your different additives or fillers. But what is the testing for the final product? So you are confirming your material or you are doing some reverse engineering, then ultimately you also need to develop your own product. So you have done that primary analysis of your base rubber and other ingredients, but you need to do test your uh, final material properties. And for that, the preparation of test pieces is very important, because if the preparation method is different, your ultimate final properties of your product will be different. So it will vary and it will create problem to uh, finalize your formulation or to do the cost analysis part also. So a test pieces must be formed before the test can be carried out. So first you do the preparation of the test piece. In many cases the test pieces can be directly molded, usually in case of uh, plastic or in case of other hard material. You have to prepare the test pieces directly with a mold. But in particular in case of elastomer, it's not directly molded. First you need to prepare some sheet or specimen sheet, and then you have to cut from that specific molded sheet. So there is a standard, that is ISO 2393, where the preparation method or dimension everything is there. And also in case of a two roll mill, if it is two roll mill, is specified fairly precisely in terms of its dimension. So what is the diameter? That is 150 mm by 300 mm long, 150 by 350. And temperature control is very much important. Temperature control is also very much important. So it should not be very if the temperature fluctuation is very much, so it will create problem in your preparation of your test pieces or preparation of your material. The condition and the time of storage between mixing and vulcanization can affect the properties of the vulcanizer. It is very much important. After the master batch preparation, before going for the final batch preparation, there must be some storage time. Otherwise, the property will vary or the property may deteriorate actually. And hence, storage in a dry atmosphere. So you must have a air conditioned room, or there must be a cross verification of your humidity of the storage chamber, and the storage time should be minimum of 2 hours in between the master batch and final batch process, and a maximum of 24 hours. And everything details are given in the ISO 471 standard. In case of compression molding, the mold is loaded and unloaded as quickly. That means that stamp must be punched and immediately it should come out. But the molding are to be cooled in water or on metal plates for electrical test or removal. Because if your material is going for the ultimately electrical application, then the cleaning is very much important. It must not be uh, contaminated, or there must not be any dirt particle. There must not be others chemical moiety, so that it will impact your electrical properties of your final product. So in case of electrical application, they are the molding are to be cooled in water. It should not be cooled by any means like organic solvent or etc. So preparation of test pieces, that's why it is very much important. And also the dimension, if it is dimensionally not equal, so the properties of your final product will be different from one sample to another sample. The next is the cutting from the sheet. So you have, for in case of elastomer, you have prepared a A4 type of sheet. After that, you should cut in a different mold size based on different testing. For tensile test, you need to cut in a dumbbell size shape. And dimensional accuracy is very much important. Why it is important? Because during the tensile test, if the dimension is uneven, so there may be formation of the stress concentration, and that will eventually leads to uh, create some flaws in your testing. The next is the cutter sharpness. Cutter sharpness, why cutter sharpness is important? If the cutter surface is not even, so there will be flaws in your cutted sample, and that will again ultimately create by formation of the stress concentration point. There are different cutter blade. It may be fixed, it may be also you can change that blade. And ISO 4661, it is given all the details about the fixed blade and changeable blade. And if the sheet is very much thick, so for that you need to use motorized type of press. And the cutting of rubber is made much easier if a lubricant is used. Sometimes you need to add some soap solution, so that that cutting blade will easily take out from the rubber sheet after cutting that rubber sheet. So these are the testing of your after the preparation of your final batch. Now you need to again do the testing of your final finished product. So from the final batch you have done the testing at your compound level, but what will be the properties when that specific compound will be further processed through different processing technique, and ultimately what will be the property remained after the product is formed. So it is obviously desirable to make test wherever possible on the actual finished product rather than on the specific prepared test pieces, because during preparation of the test pieces, the everything actually you will try to follow every aspects to get better property. But when you are preparing a product, so it is undergoing through different processing technique, so there may be some changes in the property of your final product. So apart from the difficulty of having sufficient bulk in the product to obtain standard test pieces, extra operation may be involved which are time consuming and are likely to lead to lower test result because of destruction of your molded surface. However, those difficulties can often be overcome satisfactorily by the use of miniaturized test pieces and by careful use of cutting and buffing apparatus. So, for example, if it is a conveyor belt, so you need to prepare dumbbell size sample from the belt only. For that, it will not actually, the surface may not be very smooth. In case of compound level, during the seed processing and during the test cutting, during the cutting of your test pieces, as the thickness of the sheet usually within 4 mm, so it's become easy. But when you are uh, preparing test pieces from your final product, then you need to do some other manual uh, activities like buffing of the material after cutting, we need to do buffing to make uh, evenness further better. And for ISO 4661 and BS 903, they are actually covered all the parameters, all the methods, how you should take the pieces from your final product, and how you should do the cutting or buffing of the test pieces collect from the product. Now buffing is most effective for the removal of surface, what I have already said, to diminish the unevenness or to remove the irregularities, including those left by cutting operation or moderate reduction of the thickness. So this is the open structure, that is the abrasive wheel, and that base actually can move, and here is the test sample. So it will first cut in a dumbbell shape, and then it should rub on that surface to get or to remove that irregularities of your sheet material. Now what is the requirement of standard testing method? Why you should go for the standard testing method? Now first of all, the importance of standard testing method, because anybody can do in their own way, and that cannot be uh, accepted throughout the globe. So that you need some standard testing so that everyone can follow that specific technique, and you can compare results from one lab to other lab also. So first is the competitive tool. So through testing you can explore ways to differentiate your product to gain a competitive edge, and the results of comparison testing may also provide data. Sorry. And the results of comparison testing may also provide data to challenge competitor claims. Because if your company is following the same standard and my company is also following the same standard, then only we can uh, compare the properties, and also we can challenge that okay, my material is showing this property, and the cost in case of the cost for my product is less, but until and unless the testing method are same, you cannot compete, because you cannot compare the properties also. The second one is the lower product cost. So for the quality analysis, you need to do that standard testing method. As part of quality and process control, a regular testing will help ensure your manufacturing process. So before standardizing a formulation, you need to do the test at compound level and also at final product level. After doing all this testing, you will ensure the formulation and the process condition during different processing technique. So that will ultimately that will remove some uh, product defect, and actually it will also enhance your production by reducing different processing time. The third one is the research and development purpose. So testing is very much important for any industry, for research and development lab, and also it will provide the uh, different ranking of your developed material based on different properties. So if NR based, sometimes you are making a combination of NR and SBR by 80:20 ratio, and then by following the same testing method, so you are preparing two sample, one is 100% NR based, one is NR and SBR based. By following the same standard method, same testing method, if you are getting same property, so based on that you can also reduce your cost of your material even after getting the same property. So that's why it is important for R&D also. And requirement for the doing the business, many industry require a product to meet minimal acceptable standard. Testing provides the means to show your product meets or exceeds this requirement. So for the business part, they sometimes customer need some uh, your testing test certificate from different standard lab, like sometimes they need the IRMRA certificate, For that you need to send sample. So that's why to increase your business also, if you have some standard testing method in your lab, it will benefit you from the business point of view. Now who will produce those standard? So sometimes what happen, each individual company, they have their own standard, but if someone cannot trust, may not trust on the uh, their own standard also. So for that you have to have some uh, a international or an organization, so that each or everyone can accept their standards. So the ultimate state of unity would be for all countries to be using the same standard. So you may mm, uh, if you follow that ISO standard, a industry in Germany, they are also following the same standard. So from there you can say what are the, if there is a changes in property, or if uh, the cost is same, so you can challenge also that yes, I am following that ISO standard, this, and I am getting this much of property. Then people can trust on your material also. So this would obviously be of great value in smoothing the course of international trade, and would make it easier for technologists also to exchange technical information. Until and unless you are following the same standard, you cannot comment that okay, my material is good or bad. In most fields, including rubber, the principal body attempting to achieve the ideal of international agreement is the International Standard Organization, which is hence our most important organization in the standard field. So ISO is the most important organization, and that already have different standard for different testing method, and by time to time they also revise their standard technique. For that you need to purchase from them. Any standard you need to purchase from them. Except international standard, there are also different national organization that will produce standard for their own country. So each country has one principal standard organization that provides the membership, official membership of international standard organization. Another organization can issue standard at the national level. For example, in case of India, it is Bureau of Indian Standard or BIS. In case of British, in case of England, it is British Standard Institution or BSI, and uh, in America, that is American Society for Testing and Materials, that is ASTM standard. So these are the principal organization, those are producing standard for different testing method. So here okay, so I have put few question. Before that, if you have any doubt, you can ask me. Anybody has any doubt, or I should go for that question answer session? Hello. Should I go? Yes. Okay. So first question is, so we have discussed about different chemical analysis. So which one of the following polymer will respond to the following chemical reaction? That is the filtrate after fusion, and you add then sodium nitroprusside, and you are getting deep violet color. So there are four options. So which will actually give positive result? That means if you do this test with this item, for which one you will get that deep violet color. So first one is natural rubber, second one is the hypalon, third one is polystyrene, and the fourth one is polypropylene, which will show violet color when it is uh, came in touch with the sodium nitroprusside. Anybody please? So the answer is hypalon. Because of the presence of sulfur, it will react with the sodium nitroprusside and it will show deep violet color. So here this is the nitroprusside, and when it is reacting with the S2 minus, it will form FeCN5 NOS 4 minus, and it will show deep violet color. So hypalon, that is CSM, that is presence of sulfur is there, that's why it will show deep violet color. The next question is, which one of the following polymer will respond to the following chemical reaction? That is presence of when you are reacting the filtrate with concentrated HNO3 and silver nitrate, it is forming white precipitate that is soluble in ammonium hydroxide. Among these, which one will show that white precipitate? Already have discussed it today also. If you have listened it, you can answer. And among 4 option, which will react with AgNO3 and will form white precipitate. So yes, that is absolutely right. That is PVC, because the presence of chlorine, it will form the AgCl. That AgCl actually, when again AgCl is reacting with NH4OH, so it will form NH4Cl and it will be solubilized. So this is the matching. So first is the boiling with 80% concentrated H2O sulfur. Second one is pyrolytic test. Third one ignition test and Soxhlet apparatus. So which one will be the right answer? For base rubber, you need to do this test. For base polymer, we have already discussed about different base rubber, and we have done different element analysis and polymeric uh, different analysis for different functional group present there. Okay. uh, igni- Ignition test is Gaussian burner. Okay. Analytical test, you need a glass tube. Of course, you need a glass tube as a sample container. And Soxhlet apparatus, we have discussed that here actually we separate out soluble and insoluble, no issue. So from Soxhlet, what we should do, what we do usually, we separate out the soluble part and insoluble part, right? From a compounded rubber, you do that Soxhlet uh, operation, and you are separating that base rubber and other additives. Hello. Fourth will be okay. Okay. Yes. So you match that, which among the 4, which one is 4A and third will be B. Okay. So last 2 option both are same. So I have shown that in case of natural rubber, it is decomposed when it is boiled with in 80% concentrated H2SO4. Why it actually decomposed? Because of unsaturation. So that one must be D, because if it is saturated rubber, D. So if one is D, so C, that C will be the right answer. Let's see. Yes, the right answer is C, because in case of unsaturation, that actually decompose when it is boiled with the concentrated H2SO4. The next one, which one of the following polymers will respond in Bilstein test? So this is also a specific test for a halogenated element. But here all are halogenated compound. FKM is that fluorocarbon monomer, bromobutyl. Okay, you are saying that bromobutyl. That you means that option D. Actually, it is done for the chlorine group. So PVC and chloroprene both have chlorine. In PVC there is also chlorine. In case of chloroprene, yes, in chloroprene there is also chlorine. But except these, all have different halogen. For example, here that is fluorine and chlorine. In case of FKM and chloroprene, there is also fluorine, chlorine. Here only bromine. But chloroprene actually show this test, and actually it creates some green flame during this Bilstein test. Now again, it is a matching problem. So this is that there are different ASTM standard. So which one is corresponding to which test? So tensile test, aging test. So for different test, you have different ASTM standard. Anybody else? I think only ma'am is trying. Rest all are silent. So the tensile test actually ASTM D412. Tensile test. Sorry, ma'am. Tensile test is a D412. Tensile test is D412, and your hardness, I think it is D57. Aging test is maybe D572, and hardness it may be 2240. Let's see what is the answer. Yes, B, that is tensile is the D412, aging test is your 572, compression is 395, and hardness is the 2240. Actually, I reminded these two, hardness and tensile. Okay, so uh, okay, okay. So, ma'am, you are from industry or you are from any academic institute? Okay, okay. So, today we have discussed about different standard method and different chemical analysis technique, and also uh, different preparation method of different sample, because this is very much important, the preparation of test pieces. And also I want to inform you one thing, that for specific test, like if you need to do some ozone test, so you must have some specific conditioned room for the uh, to prepare the test pieces, and ultimately before doing the test you have to have keep in that specific condition room before doing the test, otherwise the property will different. And also uh, for in case of elastomer, if you need to do the UTM or tensile testing, and for that you need some dumbbell type of sample. Yes. Now there is also, you have to have some even thickness. There must not be any air bubble formation during the preparation of your seat. That a specific seat first we need to prepare for to cut the dumbbell shape. For that you also maintain that there must not be formation of any bubbles, because when you are calendaring the seat, if there is a bubble, so it will ultimately deteriorate your mechanical property of the test sample. Even if the formulation is right, you will not get the actual result because of the defects generated during your processing of test pieces. And another thing, that there must be a time gap before doing the final batch processing, in between master batch and a final batch. And also after final batch, when you are doing the testing at the compound level, there must be some saturation time. Until and unless you are providing saturation time, your property will be different. So that's why uh, it's not only the composition, or not only the formulation, you must have to follow some standard methods before doing the testing. So uh, if you need any other information, you may mail me. I have already shared my mail. So this is the third week. So thank you for your patience and asking your queries. So again we will meet next Saturday. Okay.